1/4" MDF. This is a good material that I could use to prototype in. And then once I get the final design, I thought about going to this plexiglass, which is also 1/4". I think it'd look really nice in this, all shined up. I've been using SolidWorks to model this arm. And through trial and error and lots of playing around with it, I think I got it to where it actually moves. Look at this. So I'm pretty proud of that. It took a while to figure that out. Servo tucked under there. But modeling in this fashion is good because you can play with things and see how they're going to work and make sure you're not hitting anything before you make the final part. So it saves a lot of goofing around. But you first have to learn how to program in this manner. And I will tell you, it's quite challenging. It took me quite a while just to learn how to do simple things. It's fairly intuitive, but until you can wrap your head around how the software works, it is challenging. But you can see the results are crazy. Now, everything has to be told what to do, and this arm can actually go past what is really possible in real life. You can see I can cross these right over and flip them around to weird positions. But anyway, I wanted to show you what's possible with software, and each one of these parts is independent, so I could click on this and open this part and just get that one left gear, and there it is. So whatever modifications I make here will show up on my final design, and then I can sit here and play with it and see what needs to be done. The first thing I need to do is take this thing and make it bigger so it fits our new servo. So first I have to draw out the servo so I know how big that's going to be. So I'll be back. You can see how I can flip it around and observe it from different perspectives and see how it's going to work. Like I've noticed this block right here. Let's look at that straight on. This gear right here is hitting this piece here. In real life, this won't work. See how tight that is right in here? Yeah, it might miss it. It's the same height. Yeah, I guess it's okay. It's sliding over the top. We can see it down through here. If you're interested in seeing more about SolidWorks and how to do certain things on it, I'm no expert, but I could do other things if you're interested, but you gotta let me know. I don't even have bolts in there. I'm just referencing the holes together. I've been scaling all the parts off to 2.65 to start off with. And here's one of the bent arms. Let's go ahead and scale this. So I'll dig down here and I'll find the sketch and I'll edit the sketch. Then I go to Tools and Sketch Tools and Scale. I'm going to highlight all the pieces of the sketch so they end up here. I'm going to change my sketch scale to 2.65. I figured that out on a calculator. And then I'm going to set my midpoint to the origin. And you can see that there's how much bigger it's going to be. Let's go ahead and OK that. And there's the new big one. Let's close that. It's going back to my assembly. You can see I've still got some small parts here. Let's Let's work on the two little arms here. Open the part. Open the sketch. Tools. Sketch tools. Scale. Highlight all the parts. Change this number to 2.65 and just gonna find the origin. There it is. There's the new part. Okay. See what it looks like now. And we're gonna close and save. See what it looks like. Yeah, now we got this little piece here, a spacer. Open. Dig down, find our sketch. Edit the sketch. Tools. Sketch tools. Scale. Select all the entities. Change this scale number to 2.65 and find my origin. There it is. Click. New part, old part. As soon as you click OK and you accept it, it will get rid of the old one. There's my new one. When I close the sketch, the extrude will come back up and I should be able to close and save. Yes. There's all our new, oh, I've got one. Let's do our base here. Open part. Edit sketch. Tools, sketch tools. And there's one other part I can't forget, and that's that spacer. Scale. All the entities. 2.65. Scale it. It's just a reference point. It's not that crucial. Okay. New part. Okay, where's that spacer hiding out at? There it is, right there. Let's open the part. Tools. There's probably a lot easier way to do this, but I don't know it. This is all I know. Just from trial and error. You might be able to do an entire assembly at once. I don't know about on my version, but I bet you they've done it over time on newer versions. Okay, there's our new part. Save, close. Yep. See what we get. There's the new spacer, fits better under there. Okay, here's my large gripper. I had to draw my own servo because I couldn't find an example of it online, so I just drew this rough sketch. I know it's not perfect, but this is completely scaled, and it even works. Look at there. I think this model works fine in theory, so now I gotta break it into parts. VCarve is a great flat stock type building tool, if you will. So here's all the parts, and I've already did the toolpaths. Let's take a look at those. So let's go ahead and start the preview. cuts all those inside pieces, and then it comes back and it does the outside. And I'm doing this with a 1/8 inch tool. You can see that I put tabs on this as well. Let's turn it up on its side a bit so you can see them. There, you start to get a feel for the tabs. There's 2 tabs on each part, and I just pretty much randomly spaced them where I thought it needed a tab. There on that part. Some of these smaller parts, like these, I just put the support right in the middle and kept it away from the pivoting points. Those 1/8 inch bits that I have are just Dremel bits with a special adapter I have for my router, and I've successfully used them on even plywood before. This little spacer over here, I really don't it's going to get sucked up by the vacuum if that falls out, so I just tied it in. So those are the tabs. I'm going to go turn my CNC machine on and move the code over. I think I'm about ready. Yes. I have to go cut some MDF 1/4 inch, and I'm going to cut it 20 inches wide and leave it long. Let's go look at our piece of wood, and we'll just make our cut decisions when we see it. There's our wood. Roto zip and an adapter. There's a set screw on the side. You change out the bits. inside corners of these cuts usually are rounded off a bit, and the bigger the bit you use, the worse the radius is. The bigger the radius, so square corners are needed. That's why lasers are nice. That fits fairly well. Okay. Alright. This is just house insulation, like for doors. It's what I had laying around. What do you think? Oh. Okay, I'm gonna program in some gripper control. I'm running two 1650 batteries in series to give me just over 6 volts for that big servo. It's almost full of water. I like it.